Hello everyone. In this video I am going to demonstrate the same induction heater as we have seen in the previous video. So this is the same coil with the copper wire winded on the vessel along the vessel, and this is the stainless steel vessel. And here you can see in the previous video there was a coil of 2 microfarad. I was using 3 capacitances in parallel and it was giving me 2 microfarad, but now here I am using a single capacitor of 0.47 microfarad. You can see this is a single capacitor of 0.47 microfarad. You can see it is mentioned here 0.45 K. On the body it is 0.45 microfarad. So 0.4 microfarad you can say. So as you can see, the same capacitor is in parallel with the inductor, and I am supplying this using my IGBT, and the IGBT is being fired with an oscillator. So let us power up the circuit. So you can see here the voltage across the coil and the current across the coil, and the current through the coil can be measured here. So I have fed a voltage of 1.1 volt AC, and I am operating at a frequency of 41 kilohertz, as same as the old video. So now let me decrease the frequency. I am decreasing the frequency. You can see the voltage is also decreasing. So let me increase the frequency again. So when I am increasing the frequency, you can see the voltage is also increasing, little increasing. So we can say nearly the frequency is nearly the same. Now I am increasing the frequency further. So upon increasing the frequency further, I am now at a frequency of 100 hertz. 100 kilohertz, I'm sorry. So I am increasing the frequency further. So what I can see, at a frequency of 120 kilohertz, my voltage is maximum. You can see 1.26. The voltage is maximum at 120 kilohertz. So if I reduce it, nearly 110 kilohertz. Let me come to 100 kilohertz. So I will go back to maybe 110 kilohertz. Yes. Now I am at a frequency of 110 kilohertz, and I can see the voltage across my coil is 1.28 volts AC, and I am carrying a current of 0.448 milliamps, 0.48 amps, like 350 milliamps. So now let us increase the voltage. I am increasing the voltage now. I am increasing the voltage. So as you can see, the voltage across the coil is now 18 volts AC, and the current is 7.6 ampere. So you can see the coil inside is very hot already. There is considerable amount of heat inside. You can see there is the heat is very high inside. So if I increase the voltage further, you can see now I am giving a command of, you can see 21 volts into 9 amps, nearly 10 amps you can say. So 200 watt heat dissipation is there now at present. So it is quite hot, the vessel is quite hot. So you can see here the same coil, you can see here the same coil is used. The same coil is used, but when the capacitor is low, I am getting a voltage. The voltage, operating voltage is high, and the current is also very high. You can see the current is also very high, and the output is also very high. So that means if we reduce the capacitor, capacitance, the parallel capacitance, if we reduce, the efficiency of the inductor increases, the heat dissipation also increases. You can see. So presently I am operating at a frequency of 20 kilohertz. I am sorry, 120 kilohertz. I am operating at a frequency of 120 kilohertz, and you can see this is my voltage across the inductor. This is my inductor. You can see it is quite hot. It is very hot now. See, 21 volts AC, and it is 9.3 amps. So thanks a lot. Thanks for watching.